Okay, so on this one it says that out of school, on Friday, 3 out of every 4 students were wearing jeans. Now what I want to do is I want to use my cube method. So that's what I'm going to do, is I'm going to use my cube method on every problem. I'm going to circle my numbers. I'm going to underline my question. I'm going to box my labels. And then I'm going to eliminate any extra information, and then I'm going to solve. So it's cubes. So it says here that 3 out of every 4 students, so 3 out of every 4 students were wearing jeans, so they're wearing jeans. I have 600 students at school on Friday, and how many are wearing jeans? Here's my question. So I want to underline how many are wearing jeans. If I have a highlighter, I can also go ahead and highlight that. How many of my students were wearing jeans? So what I do know is I know that 3 out of 4 were wearing jeans. So I want to know how many out of 600 were wearing jeans. So based on that, I'm going to solve for x so I can cross multiply. When you can use a proportion, please do so. So I have 4x is equal to 1,800. I divide both sides by 4. 4 will go into 18 4 times. I have 2 left over. I can just work it out here. I'll create my T-chart with my problem and my work. So I have 1,800 divided by 4. 4 goes into 18 4 times. 18, 2, 0, 5, 20. I get 450 students. So that's what I have, 450 students. I look at my answer choices. I see that B has it, and it gives me the proportion, so that's going to be my maybe. I'll put an M there. The answer can't be 599 because it's not, I have 3 out of 4. This is actually saying that everyone but 1 is wearing it, so that's not possible. C is saying that only 50 are wearing it. Well, it's 3/4. So even if it was half the students, that would be 300 students. So that's way too low, not possible. And it can't be 800 because my max is 600 students. So how can I have more people wearing jeans than students in the school? So not possible. So the answer has to be B. All right, so in this one it says the numbers in each set shown below have a common characteristic, and it gives here some information in set S, some different numbers. We got some fractions, we got some decimals, and in set T there's some. So which statement best describes a common characteristic of the numbers in set S or T? So we can go through each one of these and either prove or disprove each statement. So F says each number in set T is less than 1/4. So I need to see if each number in set T less than 1/4. So I'll look over here at set T, and I see that this one right here is 4/10, which is 2/5, and 2/5 is going to be greater than 1/4 because 4 times 2 is 8 and 5 times 1 is 5. So that right there proves why F doesn't work. I also have set G, or letter G. Each number in set S is less than 0.65. Well, I can see right here that this is really 80/100 or 8/10. And actually 8/10 is greater than 65/100. So it's not less than, it's actually greater than, so G does not work. We have H. Each number in set T is greater than 1/2. So I'm trying to see if there's something in set T that's actually less than 1/2. And, oh, right here. When I look at this, this is 2/10, which is 1/5. And that is definitely less than 1/2. So it's not greater, it's less, so that does not work. Oh, I'm sorry, did the wrong one there. Back that up. So H does not work. So it's probably got to be J, but let's test it to make sure. Each number in set S is greater than 0.5. So I'm looking now at each one of these numbers here, and I want to make sure that it is larger than 1/2. Okay, this is definitely larger than 1/2. This is equal to 6/10, so that's larger. 5/9, well, I know that 4.5 over 9 is 1/2. And since this numerator is 5, it's greater, and it must be greater than 1/2. So this is good. And then this one also is 57 hundredths, and it's 7 hundredths larger than 1/2, so that must work. So the answer is J. All right, Kenji has a collection of rectangular prisms of different heights. Each rectangular prism has a length of 5 centimeters and a width of 2 centimeters. The table below shows the relationship between each rectangular prism volume and the rectangular prism's height. Which equation can be used to find V, the volume in cubic centimeters of a rectangular prism in Kenji's collection? Okay, so let's get started. So we have a length of 5 centimeters, we have a width of 2 centimeters, and we're trying to find the volume. So that's what we're trying to find. We're trying to find the volume here. So we know that volume is equal to length times width times height, okay? Or we know it's big B times H, and the big B is the area of the base. When we look up here at our table, we can also look for a pattern. We can look to see, well, what do we do to get the volume? Volume is what we want to try to get. So what do we do to here, the H, to get the volume? So what do you do to 2 to get to 20? And you can multiply that times 10. 9 going this way, multiply times 10. 16 multiply times 10. And then 23 multiply times 10 will get you 230. You know, we also know that the volume of length times width times height, we know the length was 5, the width was 2, and the height is H. We're trying to find it. So that's 10 times H. So it's basically take the height, multiply it times 10. And if you notice, we proved that right here. You have the height and you multiply times 10 each way. You'll get the choice of A as being your answer. Mia is 2.5 years older than Chloe. Alan is 6.5 years younger than Chloe. And Mia is 12 years old. What is Alan's age? So we have here 2.5 years, 6.5 years, we have 12 years. We have some important, we're going to underline what is Alan's age, and we're going to box these. Older than Chloe, that's huge, and that's Mia that's older than Chloe. Alan is younger, 6.5 years younger than Chloe, and I know that Mia is 12 years old. So I have Mia, I have Alan, and I have Chloe. So I know that Mia is 12 years old. That's what I know. And it says that Mia is 2.5 years older than Chloe. So I would take 12 and I would subtract 10.5 from it. No, I'm sorry, I would subtract 2.5 from it. 2.5, let me erase that. So that just stays right there. So I start with 12, and I'm going to subtract, Mia is 2.5 years older, 2.5. So I get an answer of 9.5. So that means that Chloe, right here, Mia is 2.5 years older than Chloe, so Chloe must be 9.5. 9.5 years old. Now we go back to Alan. Alan is 6.5 years younger than Chloe. So I take this number here and I subtract 6.5, and when I do that I get an answer of 3 years. 9.5 minus 6.5 gives me 3. Alan's 3. Your answer must be G. The picture graph below shows the number of samples of matter being tested in an experiment. What's really important here is that each one of these beakers represent 5 samples. So this gas right here is 5 samples. Each one of these is 5, so that's 20 samples. And here we have 25 samples. So which statement is best supported by the information in the picture graph? So there are a total of 10 samples being tested in this experiment. No, there's actually 25 and 20 and 5 gets me 50 samples. This is going to confuse people because they're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but there's really not 10 samples. There's actually much more than that. There's 50, so A is wrong. B, the ratio of the number of gas samples being tested to the number of liquid samples is 1 to 10. So that's 1 gas to 10 liquids. Actually, it's 5 to 25, which is equal to a 1 to 5 ratio. So that's wrong. The difference between the number of solid samples and the number of gas samples is 3. Solid to gas. Somebody might see this as 4 to 1, but it's actually 20 to 5, so it's 15. So that's wrong. And the ratio of the number of liquid samples to the total number is 1 to 2. Well, liquid is 25 samples based on this information right here, and we know there's 50 total samples, so we have that right here. So that reduces to a 1 to 2 ratio. So D is correct. Stephanie and Tamara both started running a race at 8:15. Stephanie finished the race in 4 hours and 30 minutes. Tamara finished the race in 1 hour and 15 minutes after Stephanie did. At what time did Tamara finish the race? So let's go ahead and use our cube method. We have that Stephanie and Tamara both started at 8:15. That's important. Stephanie finished in 4 hours and 30 minutes. Tamara finished 1 hour 15 after Stephanie. At what time did Tamara finish the race? Well, they both started at 8:15. Stephanie finished 4 hours and 30 minutes later. So if I add 4 hours and 30 minutes, that's going to get me, and this is AM, that's going to get me to 12:45 p.m. So 12:45 p.m. is when Stephanie finished the race. Stephanie finished. And then Tamara finished 1 hour and 15 minutes after that. So if I then take that and go another hour and 15 minutes, I'm looking at 2 o'clock p.m. And at what time did Tamara finish the race? That's right here. Tamara finished at 2 p.m. So your answer is going to be F. Angle NJP and angle KJL are shown below. What's the difference between the measures of angle NJP and angle KGL to the nearest degree? Now please remember that the middle letter here is going to be our vertex, okay? And there's your vertex right there. So we have here angles NJP, so here is N to J, P. We also have KJL. So KJL is going to be right here, K to J to L. And we're looking for the difference between those measures. That's what we're looking for, the difference between those measures. So to find the measure right here of NJP, there's a couple different ways you can do it. One method is, you can see here that the difference, since this is not this ray is not on the 0. It is 5 degrees above it. What's happened is this angle has been shifted up this way, going this direction 5 degrees. So what I could do is I could look at the outside here to see where exactly this shifts, okay? Actually, I'd look at the inside, and I'd see where it crosses, and I would subtract the 5 degrees. That's one way of doing it. So let me kind of take a little bit of that out so you can see it. And this actually crosses at about 107 degrees. I would subtract the 5, and I would get 102 degrees. That's one way of doing it. The way that I think works best for people, I'm just going to erase all this, is that when you look at either the inside or the outside numbers. And so out here I can see that this ray crosses at 5 degrees. I use the outside number. Out here I'm going to use the outside number, or I have where this I'm sorry, I use the inside number here at 5 degrees. And over here I'm going to use the inside number, and that's 107 degrees. I take the difference between those, and I wind up getting 102 degrees for angle NJP. If you wanted to use the outside numbers, that's fine. We can do that. This crosses between 170 and 180, so it crosses at 175 degrees. Up here it crosses between 70 and 80. That's about 73 degrees. And I could take 175, subtract 73 degrees, and I wind up still getting 102 degrees. But it doesn't matter if you use inside or outside. It just matters that you use the same. Let's do the same over here. I can see that this crosses at 0 degrees. I use the outside. So over here, this is between 30 and 40. It's right in the middle. That's 35 degrees. So the difference here is this is a 35 degree angle, and this is a 102 degree angle. I want to know the difference, so I take 102. I subtract 35 degrees. I get a 67 degree angle, which is going to be G. Each of the 3 students wrote an equation. Nicole wrote that 5 2/8 is equal to 21 over 4. Eric wrote that 5 1400 is equal to 21 over 4. And Keisha wrote that 4 1/5 is equal to 21 over 4. Which of these students wrote an equation that is true? So we're looking at which one of these wrote that is true. Now, you could have multiple people here. For example, if you look at G, Nicole and Eric were both right. And if you look at J, Nicole, Eric, and Keisha were both right. So what we need to do is go through and just find out which one of these students is correct. If you notice, they've taken 21 over 4 and they've converted them either into a mixed number or they've converted them into a decimal. So what we want to do is we want to look to see which one of these is correct. Okay, so we're going to take 21 over 4, and I'm going to make that into a mixed number. So 21 goes in, or 4 goes into 21 5 times with 1 left over. And that is also written as an equivalent decimal. It's 5 2500ths. So 21 over 4, does it equal 5 2/8? Well, 5 2/8 does reduce to 5 1/4, so I know that Nicole is right. Eric, 21 over 4, they're saying that Eric wrote it's equal to 5 1400ths. Actually, it's 5 2500ths, so Eric is wrong. Keisha wrote that 21 over 4 is equal to 4 1/5. We actually know it's 5 1/4, so Keisha is wrong. Nicole is the only one that's right. So that's my possibility, my maybe. Nicole and Eric are both right. Well, Nicole is, but Eric's not, so G is wrong. Keisha only, we just found out Keisha's not right, so H is wrong. And this is saying both Nicole, or all Nicole, Eric, and Keisha are all correct. And Eric and Keisha are not right, so J is wrong. So the answer must be F. Which statement about figure RSTU is true? So we can see here that this is a quadrilateral, and we know that all quadrilaterals The sum of the angles is 360 degrees. So I need to get angle T right now is what I need to get. So I'm going to add up 159, 129, and 17. So 9 plus 8 is 18, plus 7 is 25. 5 plus 2 plus 2 is 1, so that's 10. So that's 0, carry the 1, and I got a 3. So it's 305. I subtract 305 from 360, and I get that angle T is 55 degrees. Okay, so I know that. So now I need to go through here and I need to disprove some of these answer choices and prove an answer choice. The difference between the measures of angle T and R is 4 degrees. So T is 55 and 17. So I'll do 55 minus 17 and I get an answer of 38. So that is wrong. The difference between the measures of S and T is 95. Well, S is 129 and T is 55. So that is 74 degrees. I wanted 95, that's wrong. The sum of the measures of angle RST is 201. So R is 17, S is 129, and T is 55. So 9 plus 7 is 16, plus 5 is 21, 1 carry your 2. 5 and 2 is 7, 8, 9, 10, 0 carry the 1. I get 201 degrees, so I'm going to put an M here for maybe. And then the sum of measures of RT and U is 193. So I'm going to take my R, my T, and my U. So let's go with R, which is 17, my T, which is 55, and my U, which is 159. 9 plus 5 is 14, plus 7 is 21. Carry your 2. I can stop right there. This 1 was supposed to be a 3. So that does not work, so my answer is C. The list below shows the rate at which Riley burned calories by doing different activities last week. Playing basketball burned 11 calories a minute. Jogging burned 9 calories per minute. Basketball was 11 calories. Swimming is a total of 600 calories in 2 hours. So Riley did each of these activities for 2 hours last week. Based on the information in the list, which statement is true? So Riley did each activity for 2 hours last week. So if that's the case, swimming was 600 calories because that's 2 hours. Jogging for 2 hours, that means that's 120 minutes in 2 hours times 9 calories a minute. So I do 120 times 9, 0, 8, 1, I get 1,080 calories. And I have basketball at 11 calories per minute, so that means I would take 120 times 11, 0, 2, 1. I got 1,320 calories, right, for basketball. So it says A, he burned 1,200 calories per hour while swimming because 600 times 2 is 1,200. Well, that's true. 600 times 2 is 1,200. But it says here that swimming, he burned a total of 600 calories in 2 hours. It wasn't 600 calories per hour. So A cannot work. B says he burned a total of 3,000 calories because 11 times 120 plus 9 times 120 plus 600 is 3,000. Well, this 11 times 120, that is my basketball. This 9 times 120 is my jogging. And this right here is my swimming. And that is exactly what I did right up here. So when I add these together, carry my 1, 6, 7, 8, 9, 6, 7, 8, 9, 10. Oh, sorry, I didn't line up my numbers here. Let me rewrite that. 1, 3, 2, 0, 1, 0, 8, 0, and 600. 0, 0, carry my 1, 6, 7, 8, 9, 10. 3,000. That's bad. So I have 3,000 there. So this is going to be a maybe. He burned 1,080 calories per hour while jogging because 9 times 120 is 180. He burned 1,080 calories per hour while jogging. Okay, this is true, but it said that up here, it said he did each of these activities for 2 hours last week. So I need to know what the total is there. So not going to work. He burned a total of 74,000 calories because 11 times 120 plus 9 times 120 plus 600 times 120. The 600 isn't per hour, per minute. It's per minute. That's pretty amazing. So that's really not reasonable. So that doesn't work. So your answer is B. A swimming pool, Hector swam between 9 and 21 laps each day. Each lap is 26.8 meters long. Hector swam at the pool for 10 days. Which of the following is a reasonable estimate of the total number of meters Hector swam? So we're going to use our cube method. So I'm going to circle here my numbers. I have I'm going to box my labels here, talking about laps, days. And I'm going to underline my question. Which of the following is a reasonable estimate of the total number of meters Hector swam? So we can go on the low end. It says that he swam between 9 and 21 a day. So I can do somewhere right in the middle, which would be about 15. So 15 laps is about right in the middle. 15 laps, and each lap is 26.8. I could round this. You could round to 25 if you wanted to. So approximately 25, maybe even round to 30. So I'm going to take 15 laps, and I'm going to multiply that times 25 meters. So when I do that, I get 375 meters within those 15 laps. Now he does this for 10 days. So I take 375 and I'm going to multiply that times 10. I get 3,750 meters total. Now, there is no 3,750 here, but this one, C, is the closest one to it. Both A and D are going to be very low. B is going to be kind of high. C is going to be a reasonable estimate right there. So 4,500 meters. All right, so the measurements in the list below have a characteristic in common. The 2 miles, the 72,000 inches, and the 3,000 feet. It says, which statement describes the common characteristics? Now, as I look at each one of these here, I notice that they're all talking about yards. So I really want to get all of this convert into yards. So I would look at my formula chart, and I know that 1,760 yards is equal to 1 mile. So I would need to take this number and multiply it times 2 in order to get how many total yards that would be. The answer to that is 3,520 yards. Okay. We have here, I'm going to skip the inches for now. I'm going to go to the feet. I want to figure out how many yards this is. Well, I know that 3 feet is equal to 1 yard, so I would take this number here, divide it by 3, so I get an answer of 1,000 yards. I now want to get my inches, and I want to convert that into yards. Well, I know that there are 12 inches in a foot and 3 foot in a yard, so that means there are 36 inches in 1 yard. So I have 72,000 here, and I'm going to divide that by 36. I get 2,000 yards. So I'm going to go through each of my statements here. Each measurement is less than 4,000 yards. Okay, that's a maybe because each one of these is less than 4,000, which means the original are. Each measurement is greater than 1,760 yards. That's not true because of this one right here, so just disprove that one. Each measurement is equivalent to 1,000 yards. No, two of my measurements are not, so that's wrong. Each measurement is equivalent to 3,520 yards. No, my bottom two are not, so my answer choice must be A. Okay, which ordered pair appears to be located 350 units to the right and 700 units up from point W? So I'm talking about 300 units to the right and 700 units up. So I'm going to start here, and I want to go 350 to the right. So I'm going to go 350 to the right, and then I want to go 700 up. Okay? So I notice here that on my x-axis that from line to line is 350 because two of them is 700. So the same deal. This is 350. Now from here to here is another 350, so that's 1,050. From here to here, that's going to be another 350, so 1,050. So I'm going to start here and I'm going to go over to the right, 350, which means I go over one entire block. So I started in the middle. I'm going to go over to right here. Now I'm going to go up, it says here, 700. Well, going up 700 skips 2. So from here I'm going to go 1, 2. So it places me right here. So what I now need to do is I need to figure out what is the ordered pair for this area right there. That's what I need to figure out. Well, obviously I know that my y-axis is here is at 1050, so A is gone and B is gone, so I'm left with B or C. So I start at 0, I go past 700, I go right in the middle, which is going to be 875, because 175 is half of 350. And I go up to 1050 right here. So my answer is going to be C. 875 is my x. 1050 is my y. Okay, at 7:26 a.m., Dante started delivering packages. At 10:34 a.m., he delivered the last package. He delivered a total of 18 packages, and he spent about the same amount of time delivering each package. Which of the following is the best estimate of the number of minutes Dante spent delivering each package? So, we know that at 7:26 a.m. is when he started. We know at 10:34 a.m. is when he was done, that he got his last package done. So he delivered a total of 18 packages, and he spent the same amount of time delivering each package. So the question is, what's the best estimate for the number of minutes he spent delivering each package right there? So what we have here is it's an elapsed time problem. We're going from 7:26 a.m. and basically we're going to 10:34 a.m. Well, I can just take this and make this about 7:30. And I can make this about 10:30. So what we did is we went a total of 3 hours. That's how much time has passed. So of that time, that 3 hours is equivalent to 180 minutes. And he delivered 18 packages during this time. So I could take my 180 minutes, divide it by 18 packages, and that will get me how many minutes per package. So I could set up a proportion if I wanted. So X minutes for one package, cross multiply and divide, and 18 goes into 180 10 times. So it was approximately 10 minutes per package. Okay, so F would be your answer. G is 3 hours per package. What about the other 17? This is an hour per package, so you can only get 3 delivered. This is 20 minutes. He's not going to get all 18, he's only going to get 9 of them delivered there. So not reasonable. F has to be your answer. On Saturday, Ricardo drank a total of 40 fluid ounces of water. If he drank m fluid ounces of water that morning, which equation can be used to find n, the number of fluid ounces of water he drank the rest of the day? So we know that 40 ounces here, 40 fluid ounces is the total. And m represents morning, and I want to find n that he drank for the rest of the day. So I would start with my 40. I would need to subtract my morning, because let's just say it was 25 ounces. And that is going to give me n, which is the rest of the day. And in this case, it would be 15 ounces. Okay. A good strategy sometimes is to actually solve. Put in, make up a problem, put in a number here to see if the solution works. So 40 minus m is equal to n. F is going to be your answer for that one. Which angle does not appear to have a measure of 160? So I want to go through each one of these angles here and see which one does not appear to have a measure of 160. So here we are, we have BTY, so I'm going to go from B to T, and then from T to Y. One wonderful way about doing that is to just look at the outside numbers or the inside numbers and then subtract the two, where the two rays cross. So this one, for example, will cross approximately, I'm going to use the outside at 10 degrees. Over here, the Y crosses at 170 degrees. If I take the difference between the two, I get 160 degrees. Now we are looking for not 160, so A cannot be the correct answer. WTZ. So I have W crossing at 20 degrees. I have Z crossing at 180 degrees. Take the difference between the two and you get 160 degrees. So that is not possible either. WTY. So the W crosses at 20. The Y crosses at 170. Take the difference and you get 150 degrees. So that's a possibility. Now we have UTX. U crosses at 0, that's my outside number. X crosses at 160. Sorry about that. X crosses at 160. So I get 160 degrees. So that's not possible, so C has to be my right answer. All the minutes used by Mrs. Larson and her 3 children for cell phones last month were reported on the same bill. So it lists all this information here. It says the expression below can be used to find the number of minutes each of Miss Larson's daughters used. What was the number of minutes each of Miss Larson's daughters used? So this information is helpful, but really all I need to do is solve this. So I can use my order of operations in order to solve that. So I have my parentheses and my division. Now inside my parentheses I have subtraction, subtraction, and multiplication. So what I'm going to do is I'm going to multiply first. And I'm going to do my 462 times 2. And I get an answer of 924. So I get 1850 minus 462 minus 924, still in parentheses, and divided by 2. So I have now still my parentheses and my division. In my parentheses I have only subtraction, so I can work left to right. So I'm going to do 1,850 minus 462, which is 1,388 minus 924. I'm going to divide that by 2. So 1,388 minus 924 is 464. Divided by 2. And I get an answer of 232 minutes. And that proves that J would be the correct answer. An adult human body contains 10 pints of blood. 10 pints of blood. How many fluid ounces is equivalent to 10 pints of blood? So I need to find out how many ounces, fluid ounces, is equal to 1 pint. All right. So I'm going to use my land of gallon. And so I have my big G, and I have my 4 queens, or my 4 quarts. Inside each one of those, I have my 2 pints. Inside each one of the pints, oh, I'm going to have to just enlarge it. I have 2 cups, and then in each side of those cups, I have 8 fluid ounces. So there's 16 fluid ounces, basically, in 1 pint. So I know that I have 16 fluid ounces is equal to 1 pint. So I have 10 pints of blood, and I want to find out how many fluid ounces that is. So I have 16 ounces is equal to 1 pint. So if I have 10 pints, how many ounces is that? Well, let's just cross multiply our proportion, and X is equal to 160 fluid ounces. There's your answer.